Have you ever stopped to think about what's really going on inside that phone in your pocket? Well, today, we're going to pull back the curtain. We're going deep inside a classic Samsung Galaxy S5 to uncover a secret computer, one that holds the keys to your phone's entire connection to the world.
So let me ask you something. You know your phone has a brain, right? The processor that runs all your apps, your games, your camera. But what if I told you it has two brains, and that the second one operates completely in the shadows, totally separate from Android? That's the one we're here to talk about.
Okay, let's break this down. It's actually pretty simple when you see it laid out. On one side, you've got the application processor, the AP. That's the brain you know and love. It runs Android, it handles TikTok, it's the part you interact with. But on the other side, you've got the core processor, or CP. Most people call it the baseband. This thing is a whole other computer, running its own secret operating system, and it has one single critical job: to handle every single bit of communication over the cell network.
So how in the world do you even get access to this hidden processor? I mean, it's not like there's an app for it in the Play Store, right? To get in, you have to use these special access modes, which are basically the keys to the kingdom. And they were designed for engineers, but as you can probably guess, they can also be used by threat actors. For Samsung phones, the master key has a name: Odin mode. You might also hear it called download mode. Now, this is not part of Android. It's a special state the phone boots into that gives you raw, direct access to the hardware. Think of it as a powerful, leaked internal tool that lets a service tech, or anyone who has it, completely rewrite the phone's most fundamental software. And getting there involves what is basically a secret handshake. It's a specific, weird button combination. For this old S5, you hold the volume down, home, and the power button, all at the same time while the phone is off. That right there is your first clue that you are entering a part of the phone that normal users are never ever supposed to see.
Okay, now this is where it gets really interesting. Look at how the phone's software is broken down. When you use Odin, you're not just flashing one giant file. You're flashing individual pieces. You've got the bootloader, the BL, the main Android system, that's the AP, carrier-specific stuff in the CSC, and then the one we care about, the CP. That little file is the entire operating system for the phone's second brain, the baseband.
All right, we've found the secret door and we've got the key. So let's step through and get properly introduced to the phone's second brain, the baseband processor.
The best way to think of the baseband is as a hyper-specialized diplomat. It's a computer within a computer, and its only job is to speak the incredibly complex languages of cellular networks. It takes raw radio waves, literally plucks them from the air, and translates them into data that Android can understand. And it does all of this completely on its own, in total isolation. It's a functional black box. And just when you thought it was complicated enough, get this: not all Galaxy S5s are created equal. Depending on where you bought it, you could have a model with a Qualcomm Snapdragon chip or one with Samsung's own Exynos chip. And this highlights a massive security problem. They use completely different baseband systems. Qualcomm uses one type, Samsung uses their own proprietary Shannon baseband. That means different hardware, different software, and yep, a totally different set of potential security holes, all being sold under the exact same product name. Okay, so if the baseband is this sealed-off black box, how do engineers even work on it? How do they fix bugs? Well, they use hidden communication channels, special diagnostic modes that let them, whisper commands directly to the modem, completely bypassing the main Android OS.
And we're not just talking about abstract concepts here. On the Qualcomm version of the S5, these are actual interfaces you can find right in the phone's file system. You've got these ports for spitting out raw system debug logs, others for classic modem AT commands. It's an old-school language for controlling modems. Newer systems use more modern protocols, but the principle is exactly the same. These are direct phone lines to that second brain.
Now, the reason these channels exist is actually critical to making our phones work in the first place. I mean, when your call drops or your data connection is crawling, engineers need these diagnostic tools to figure out what went wrong. They can pull modem logs, see network stats in real time, all to troubleshoot that incredibly complex dance of cellular communication. But, and you knew there was a but coming, this is where the story takes a much darker turn. Because a tool that's built for diagnostics can also become a weapon. When a threat actor understands this hidden complexity, they can turn those engineering backdoors into incredibly powerful attack vectors. They can create ghosts in the machine. And that leads us to the absolute holy grail of hacking: the zero-click attack.
This is exactly what it sounds like. It's a cyber attack that requires zero action from you. Nothing. You don't click a bad link, you don't open a weird message, you don't install a shady app. Your phone just has to be turned on. That's it.
And please, don't think this is just some academic theory. The risk is very, very real. Just look at this number 18. In a very short span of time, the elite researchers at Google's Project Zero found 18 zero-day vulnerabilities in Samsung's Exynos modems, the direct descendants of the Tech NRS5. These were brand new, previously unknown flaws, leaving millions of phones totally exposed.
So let's walk through how a real attack like this actually works. An attacker, all they need is your phone number. That's it. They craft a special malicious data packet and send it over the Voice over LTE network. Now, because the baseband is the gatekeeper for all radio traffic, it grabs that packet and starts processing it before Android even knows it exists. A tiny flaw in the baseband's code causes it to crash, and in that split second of chaos, the attacker injects their own code. Boom. They now control the modem.
And don't just take my word for it. The researchers at Google put it very bluntly. They said a skilled attacker could use this knowledge to compromise phones silently and remotely. They become a ghost living inside the radio of your device, completely invisible to Android and all of its security protections.
So, what's the big takeaway from all this? It's that this deep, hidden layer of computing inside our phones is a total paradox. It's a double-edged sword, constantly balancing incredible power against a profound and almost invisible risk.
I mean, think about it. On one hand, these are necessary tools. Odin mode can literally save a bricked phone. Those diagnostic ports are absolutely essential for debugging. All this complexity is what gives us things like 5G. But every single one of those tools can be flipped and turned into a weapon. Low-level access creates a perfect attack surface, and the fact that this code is all secret and proprietary means that critical bugs can stay hidden for years.
So I'll leave you with this final thought. The baseband processor, that second brain in your phone, is arguably the single most critical computer you own. It is your connection to the entire world. And yet, it's the one you know almost nothing about. It really makes you wonder, what other secrets is it keeping?